We have done delta to Y conversion in the previous video. So three circuits arranged in a delta shape, and we have found for the equivalent Y value, we have substituted the delta arrangement with a Y arrangement, and we have derived the Y resistance values for that uh, equivalent arrangement. So we have done that for three resistances. Now what we want to do, we know these are the expressions. So if this is the delta arrangement RA, RB, RC of three resistances, the equivalent Y for the same three nodes will have R1, R2, R3, and R1 is given by that. R2 will be again RA plus RB plus RC, and in the numerator will be, since we are calculating R2, that will be the resistance connected to B, so RC and RA, and R3 will have RA plus RB plus RC, and that will have this one R3, so this is C, RB times RA. We have seen that previously. Now we want to find from these equations, using these equations, not from the circuit, we will derive RA and an expression of RA, RB and RC in terms of R1, R2, R3. So basically we will now try to find the expression where we can substitute a Y arrangement with a delta arrangement basically. So what we will do, let's name the equations. This one is 1, this is maybe 2, and this is 3. So first I will do, let's divide 1 by 2. We will do the division, not subtraction or anything. So R1 over R2, because we can see few things will get cancelled, and this will be RB RC divided by RC RA. So RB over RA, that's what it will become. Let's call this equation 4. Now let's do equation 2 divided by, equation 1 divided by equation, let's keep that 1. So equation 1 divided by equation 3. So that will give us R1 divided by R3, and will be RB divided by RA. I think there was a mistake, so it will be RC divided by RA. So that's 3. Yes, that will be RC divided by RA. Sorry, RC divided by RA. So what we get from 3 and 4, or this is, let's call this equation 5. So from 4 and 5, from 4 we can say that RB, we can write RB in terms of RA. So that will be RA R1 over R2, and from 5 we can write RC in terms of RA and those two, so that will be R1 over R3. Now these two values we can substitute back in this equation, equation 1. So equation 1 is R1, RB and RC. So this is our equation 1, RA plus RB plus RC. So if we substitute RC and RB with RA, so that will become RA times R1 over R2 times here RA R1 over R3, and in the denominator will be, of course, RA will be RA, this will be RA R1 over R2 plus R1 over R3. So we can see that here we have R1 on the left hand side, and here we have RA square on the numerator, divide times R1 square R2 over R3, and in the denominator will be RA 1 plus R1 over R2, R1 over R3 plus R2 plus R1 over R3. What I'm doing here is pure algebra, nothing else. So this one is RA now, because RA and RA square, and R1 here. So this is R2, R3, R1 square, and here R2 over R3, and this is becoming R2 times R3 plus R1 times R3 plus R2 times R1 times R2, sorry, like that. So this is now, and all I have done is I have added these three terms, so it's like that. So this is now R1, and here we have RA square and R1 square. So what will happen is this one will go in the numerator when I divide this one by this one, this fraction by this fraction. So these two will get cancelled basically. So we have this thing, and then R1 times R2 plus R2 times R3 plus R1 times R3 basically. And sorry, this is just RA now because I think I have done it previously. Yeah, this is just RA now. So what we end up getting is RA equals to R1 times R2 plus R2 times R3 plus R1 times R3 divided by R1. This is our expression for RA, that is the delta equivalent of the Y circuit. So these are all Y values which we assume that we have, and we are trying to convert the Y circuit, Y arrangement into a delta arrangement in this problem or in this exercise. So what we can see here, there is also a pattern. So when we go back here, we want to find RA, and we can see that RA is the resistance connected between node B and node C for the delta. So what we have in the denominator is the resistance connected to the other node, because this is between B and C. So what is the resistance connected at the other node, which is A? That will be in the denominator, and in the numerator will be R1 times R3 plus R1 times R2 plus R2 times R3. That will be it, and this will repeat for the other two. I won't derive it, but one can try this as an exercise. So RB will become, similarly here, R1 plus R2, R2 plus R3 plus R1 plus R3, R1 times R3, and RC will become again the same thing in the numerator. And for RB, since RB is here between A and C, for RB, then in the denominator will be R2, and for RC will be in the denominator R3, because RC is between A and B. What is the other resistance? What is the resistance connected? Sorry, what is the resistance connected in the other node for Y, which is other node is C, that is R3. So this will be R2 here, and this will be R3 here, and this will be the same thing as this one, numerator. So this is how we can remember the expressions. It is easy, just remembering the pattern. So we had a system for Y to delta connection, and for delta to Y also we have some pattern, and it's easy to remember. That's what we have to do often whenever we will need this conversion. So yeah.